So today we are going to look at one more algorithm. This is called binary search. In order for this to work, the array has to be sorted. Binary search does not work unless the array is sorted. This is the basic algorithm. We find the middle of the set. And the way the AP exam will do this is by taking the low plus the high and integer division 2. When they say low plus high, we're talking about the values. Then it's going to check to see if the middle point that we just found is the value. If it's not the value, we're going to see, is it too low? If it's too low, we set the high to the middle. If it's too high, then we set the low to the middle. In effect, we're cutting the list in half. And then you do it again. We repeat this process until we either found or the high is less than the low. In other words, it's not in the list. Right? If the high is less than the low, that means we crossed over and it doesn't make any sense anymore. So those are our two conditions to stop this. Since we have a condition to stop it, essentially a base case, we could do this recursively. We could write an algorithm and do it, or write code to do it recursively. It's not done recursively for the AP exam. They use an iterative loop. They use a while loop. So when you're looking at the code on the AP exam, this one's not going to be recursive. There's another one that's recursive. They do this one just with the while loop. So here's the algorithm that the AP exam follows. Set the left and the right to the minimum and maximum indices of the elements respectively. Loop until target is found or target is determined not to be in the list by doing the following for each time through the loop. Set the middle to the index of the middle item in elements left to right inclusive. And the way they set the middle is because it's left plus right divided by 2, integer division divided by 2. If the target would have been in elements left, elements middle minus 1, then set the right to the maximum index for that range. So in other words, we're going to look on the left-hand side of the list. If it would have been on the other side of the list, set the middle plus 1, so we're going to go to the right of the list, and set the ending elements right and leave that alone as the right. So essentially we're just changing either the left side or the right side, depending on whether the list is on the left-hand side or the right-hand side, or the value, I should say, the target is either on the left or the right. Otherwise, return the middle, because that's the right answer, that's the target. Right? If it's not on the left, it's not on the right, it's got to be in the middle. Return -1 if the target is not contained in the elements. So that's effectively what the code does in the algorithm. And here's what the code looks like. They give you the precondition, the postcondition. It has to be a sorted list. It's got to be an array of ints. The way this is set up doesn't always. You could write this with an array of strings, an array of anything that has a compare to method you could do this with, but you'd have to rewrite the code. So the reason I'm pointing that out is because this is the code the AP exam uses. Therefore, when they ask about binary search, it's going to be with ints. That's it. It's going to be an array of ints. So you kind of already know something about the questions they're going to ask you. It has to be an array of ints. The big clue that lets you know this is binary search is this line right here. Left plus right divided by 2. As soon as you see that, it's a binary search. They may not use the words left, right, and middle. They may just to throw you off, so you don't know exactly what the code is doing. They could use some other words, bad variable names. So you don't recognize what it is by the words, but you should recognize what it is by the left plus right divided by 2. It's a while loop, and essentially all we're checking is while the left is less than or equal to the right. If the left goes past the right, then we know we've gone too far. You know, it's not in the list if we do a crossover. That's our stop. That's our base case. The other base case is a return that it found it. So this kicks us out, return middle. That's the only return in there. Or when left is less than or equal to middle. If none of those work, it returns -1. That's the other kick out. Remember, you have to make sure there's always a way to return a value. So either it returns the middle or it's going to return -1. Those are the only two possible returns. It's going to return the actual solution or returns -1. We start with the left equal to 0. The right is the end of the list. And then we're going to look at the target, compare it to the middle. If the target's less than the middle, we set the right to 1 less than the middle because we don't need to include the middle anymore. If it's greater than, then we set it to the left to the 1 plus the middle. If otherwise, we found the target. If it's not less than, it's not greater than, it's got to be equal to. We found it. Advantages, very fast. It's extremely fast compared to linear search. Linear search, you have to go through every single element of the list all the way through. Disadvantages, it is more difficult to code and the array has to be sorted. Now, doing this recursively does clean up the code a little bit, but it does make it a little bit more difficult in that it's a more abstract concept. The AP exam is not going to use recursion to code this. They are using specifically this code. And there's nothing on the website that I've seen that says they're going to do anything different this year. Unfortunately, their course description still says 2014. I don't know why. That's what they have up there. If somebody finds something new that says 2017, that'd be great. But when you click on the 2017 link, it gives you the 2014 course description. I'm assuming that means that they haven't changed anything really since 2014. So that's the entire binary search. Let's go through and take a look at how this works in process. So there's a nice video demonstration. What I'd like you to do is to watch this video demonstration to see how the sort actually goes through compared to linear search. And then we're going to go through and do our own little search so you guys can see that process as well. So here's a list for us to find a target. I'm going to tell you the target's 13. We have to find out the index and find out where it is. This is arbitrary for us because we're just looking at it and go, oh, there it is. But imagine this was a million elements. This would not be so quick for you to find the elements. So the computer has to go through and find it for you, or even more realistic today in today's world, a couple million elements. Even just looking at it would be insane. So we're going to index this 0, 1, 2, 3, 4, 5, 6. So the length is 7. But for our left, we're going to set the left to 0, and the right is not going to be set to the length. The right is set to the last index, which is 1 minus the length. And then to find the middle, we do integer division. 0 plus 6 divided by 2. So the middle, 0 plus 6 divided by 2, integer division gives us a 3. So this is our middle now. We have to say, is our target that we're looking for bigger than 12 or smaller than 12? If it's neither of those, then 12 is the target. So 13 is bigger than 12, which means we take this entire half of the list and throw it away. Now we're going to do it again. Left becomes 13, which is one more position than the middle. So the middle was here at 3. We throw the middle away because it's not part of the solution. We go one more, so the left becomes one more than the middle because we're on the left-hand side. Right? Made a mistake. Not 13. the index, 4. Then the right doesn't change, that's still 6. The middle, integer division. 4 plus 6 divided by 2, so that gives us 5. So our new middle, get rid of this middle. Oh, I did red, there we go. Our new middle is 78. We have to say, is it to the left or to the right of our value? Well, we look, 13 is smaller than 78, so it's to the left, and we throw out all of this. So now this part gets a little weird. Like, oh, we found the target, but the computer doesn't say, oh, I found the target. The computer still doesn't know that it found it. So it has to do the same algorithm, which would be set the left stays the same, right? The left is still going to be 4. The right now is going to be 4. Make sense? And then we have our middle, which is 4 plus 4 integer division by 2, which is also 4. So now the algorithm looks at this and says, okay, here's our new middle, it's 13. Is 13 less than 13? No. Is 13 greater than 13? No. Therefore, this must be the target. That was that last option in the code. Right? Down here, return middle. If the target is not less than the middle, the target is not greater than the middle, we must have the middle. The middle must be the target. And at that point, we return it. If that never happened, we do this again, and the left will be on the other side of the middle. It wouldn't make any sense. The loop would stop. We'd return -1. That's it for the lesson. Never stop coding.